Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hey, I'm John.
And, we don't have Ed with us. He's had to run some family errands this week, so he is not able to join us. Last week we covered a lot of the 3D scanning and how that is used, which we'll cover that again probably next week with Ed. We'll bring him in because that's something that we find interesting, something that we can find usable. I've definitely been following some of the forums and some of the, I guess you could say, social media channels and stuff like that for the scanner I'm getting and seeing what people are doing with them. They've figured out a way to get into dental practices and stuff like that right now. So
Makes sense.
they're kind of being used for everything.
Yeah. I remember getting standing in that machine, having to bite down on a certain like the X-ray machine or whatever at the dentist, and they would make a mold of your teeth. So
yeah,
it makes sense.
But this week we're going to talk about welding in space. Not welding, but sorry, 3D printing in space. Sorry, I had welding on the mind there for a second. 3D printing in space. The big thing is, when you think about it, it's, we'll probably take it to multiple different ways. You think, getting to space, coming home from space, and, while I'm there, I might as well do something productive, type of 3D printing.
Right.
So, what are you thinking?
For me, it's such a broad topic, I should say, that I could take it in a lot of different directions. But I think I kind of want to go with, like, if I was just an average, person that was interested in space or anything like that, what would I say? What questions would I ask? So it's like, how do we get into space with 3D printing, right? So using 3D printing as like a means to build whatever rocket, like Relativity Space is immediate, like one I'm thinking of, because they not only did they make a process very simple to, very simple to make a rocket engine, top to bottom. They built it. The other side of the house is that they've reduced the amount of time it takes for rocket launches, so we're able to get more objects into space. So for me, I think that printing in space is a goal, though. Printing in a vacuum is something that, like, I've got questions about. I don't know enough about, but it makes me curious, because we talk FDM printing, we talk resin printing, and these are all different chemical reactions or certain types of processes to get materials down. I'm very curious on how things are affected in space. I've read a few things, and kind of it's hard to experiment in space because it's just hard to get into space. So I think that that would be where my mind goes. And honestly, I don't know if you've thought about it much, but like we watched the Terran 1 launch. It was crazy to see. I got it as my screensaver. So we know
Methalox.
we know that a print can withstand the force needed to get it into orbit. So to me, that answers my question: how do we get there? They figured it out. They got Kuka Robot Arms. Was it the Stargate printer?
Yeah, Stargate. They got multiple.
Yeah, so they've got it down to a science, but they took rapid iteration to space and to aeronautics in that sense. But like, you can't treat the same rocket. Like, if we got to the moon, let's say, and I want to build a rocket and shoot it off of the moon or something, or Mars, and build a rocket and I want to shoot stuff back to Earth or whatever, we're exchanging resources, would I still have the same printing method?
That's it.
You
got a point there.
Would I treat it the same way? Like, how do I print when I get into another place that's not Earth?
Right, a caustic environment or something that's going to be, a problem. It's like when you start thinking about we've been, ironically, ever since really you started seeing the dawn of 3D printing, somebody has figured out how to make a combustion chamber. Um, on most of the rockets now, most of the complex combustion chambers are 3D printed. SpaceX has been doing it. A lot of people have been doing it. But, relativity is the one who, took it, well, to a whole another level. And figured out how to do wire weld FDM. I guess you could say, because it's printing with a robot. It's using a big long cable, which honestly, if you put two and two together, it's FDM. I,
Yeah.
I guess.
Yeah.
Um, if you think about it in a weird way, the Stargate is one giant FDM printer. It's got material cable, and the extruder is the big welder on the end. Um, but the thing is we've been seeing like 3D printers making the International Space Station since 2014. Throughout the years. So, and the thing is I was reading something that their biggest problem they have is the fact that every material acts differently when it gets there. They're not exactly sure what it's going to do. Like they just got
Yeah.
their first metal 3D printer, I think, just recently, if I'm not mistaken.
That makes a lot of sense. Yeah. I mean, you like we can touch on. I mean, the material sciences just in and of itself. We're not even done experimenting on Earth. Like Adidas making the shoe that's able to withstand like however so many steps. I think it was like 9,000 or something like that.
Mm-hmm.
90 miles or something like that. But we're innovating here and using thermal and um, other bonding ways, curing methods, things like that, to make a print sturdy and strengthen it. So I mean, I think it's just a matter of doing. Who's gonna be up there? It's hard to know what to do,
Mm-hmm.
but I think one of the biggest issues that spaceships and astronauts have to work on is we were talking about the cold welds earlier. You're absolutely right. Is how do you plan for the unexpected, right? Because you don't experiment like with cold welds on Earth. Well, probably do now, but like you
Mm-hmm.
don't before you go into space. You don't experiment on that.
Right. And, the last thing you want to do is you want to have a, all hell moment. You know, um, we've all had them, when it comes down to with 3D printers and stuff like that. Everybody's had one of those moments. And it's never an aha moment. It's all hell.
Yep.
It's never anything good. Um, but which kind of makes me wonder. We're dealing in a zero gravity or low gravity, environment, up there. And we start talking about the powder bed fusion,
Yep.
and you start dealing with stuff like that. How do we make sure there's no gaps in between the layers of powder bed fusion, because the actual powder should be impacted by um, gravity unless the printer is under vacuum?
Yeah, it's that exactly. That's so it have to be under vacuum, which in my eyes, if there's no external force on that, essentially it could still work because it's welding, right? So even light in a vacuum moves at the same speed. So yeah, it's crazy to see. It's like one of those experiments that I would like to try, right?
Mm-hmm.
So
It, yeah, that's weird because it's
that's
like
what
when
I
you
would expect at least.
exactly, the thing is, you definitely think of that you may have particles not all there because things are getting up and moving or shifting or something like that. It lays the powder, then it comes back and zips it with a laser little by little. So it's like,
Hmm.
does it ever make it to the end without having a problem? But that's probably something that the bigger brains at NASA have quite figured out. That, hey, we can figure this thing out by working around a problem, which is a million mile an hour problem. But
Sometimes ignoring the problem gets you to another solution. Yeah.
yeah, that's always an option. You
Where there's a
know,
will, there's a way.
you're right.
I mean,
And
that's true. Yeah,
you
it's
know,
hard to do.
yeah. And the thing is, we think you think about how hard it is to print, well, on this planet. Um, could you imagine when we start getting colonization, um, and other parts? I understand that 3D printing, as far as the orbital reaches of the International Space Station, are there to help with curing of diseases, finding of new molecular structures, supporting material sciences and stuff like that by the National Science Foundation, amongst other things. Maybe they might find something fun to do, but for them it's work, 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 work. Not a whole lot of fun. Yeah, but I don't see how floating around in space and looking down at Earth is a boring day. But
Yeah,
still.
right. That's what I was gonna say. Well, after 180 days of it, you're like, all right. No, I
or
don't think it would change for me, to be honest with you.
or if you're our Canadian colleagues, 360 something. You know,
Yeah.
um,
Well,
he was up there for what, a year. But
yeah, he said he wasn't. He didn't. He didn't enjoy it.
yeah,
I mean, you start to experience like muscle degradation and or muscle atrophy and things like that. Like it's also not good for the psyche to be
hmm
alone for that long, right?
well,
Because I
some
mean, he
people
had
say it changes your taste and stuff like that.
yeah. So.
But
But yeah, it's not. I mean, you raise a good point. You have to not only think about the materials, but like, what about the operator, right? Like, are we gonna have these as AI if they're printing in space? Like, are we able to put a some type of software package onto a we're able to do a lander like that, put a software package on there and have it automatically land, right?
yeah, and code it halfway between before you even get to the ground. Yeah.
Hey, well, listen, is every code perfect and not all code made the same?
No, but sometimes you have to make sure you put a sign on a switch that says "Please hit me."
Yeah,
You
so you
know,
make that one like orange or red.
it wasn't part of the work instruction.
Yeah,
Um,
we left it out.
yeah, good old IM1. If y'all haven't want back to watch that landing, go ahead and go back and do that. That was pretty cool. Um, but like you said, using AI to do that type of stuff. If you think about it, you can easily do, with the AI part, you're doing like a 3D printing CRM, as far as, orbital CRM with 3D printing. It's, hey, I'm low on this part. Let me print another one. I'm low on this part. I'm printing another one. Always
Yeah.
keep the stocking ranges high, and now if you start dealing with, hey, we're printing on the moon, the moon has a whole other gravitational problem. Um, so,
Yeah.
that's one thing you got to deal with.
I would think that would be phase one though. Like if I was like trying to work on like printing in lower gravity, the moon still has it's in Earth's gravity, so it's got a little bit of the gravity. So I think that would be a good place to start and experiment from. I
hmm
think, I mean, in my mind, and they're probably, I think we read plans on this, but the moon, there needs to be a lab on the moon. And I'm not saying that. I mean, we could treat it like we treat Antarctica. Like we have like posts where there's people like experimenting, finding, learning new things, like monitoring the glaciers, if it's a reduction, movement, water levels. Why can't we do that the same with like the moon? Like they've mapped a lot of the craters, but like you set a base on the moon, that's a lab. You can also experiment on what they keep trying to put a lander on the dark side of the moon.
hmm
So I mean it's freezing, but you just have to be in a spacesuit, right?
Orbital penguins. It's. I think you're onto something, but and I think that the fact that if you have an orbiting lab, not just as the ISS or what's soon going to be the orbital reef, um, and then which is a whole other bag of animals. Orbital reef. Then you've got the Artemis outpost that's going to be circling the moon, gateway. Um, then you have whatever is going on the surface, conducting experiments and stuff like that, on board the landers and stuff like that, as far as, from SpaceX and from Blue Origin. If you start thinking about it, you start bringing 3D printers down. You can start using those 3D printers to develop your tools. Because the thing is it's like, hey, I need this new tool, but I need to do this. Okay, well, let me send the CAD file via satellite uplink to your 3D printer. And your 3D printer starts printing that.
Yeah.
That could be a way around the logistical issues, and stuff like that when you start talking about long range, because the deep space networks from NASA can easily shoot that material deep into the um the far reaches of the orbital atmosphere.
You make a good point though. Like, I mean, they're able to get you resources and get you files and things like that. So like, it's such a good position for I guess experimentation. I mean, you could see how things behave, and then we could test them a little bit easier. Um, getting to Mars, things
Hmm.
like that. So.
You start dealing with over the horizon manufacturing at that point.
Yeah, yeah. I mean, at a certain point, it's not gonna. All of it's innovation, right? At a certain point, it's gonna be. We're gonna have to rapidly iterate, so rapidly prototype. But we're also like, if you can get that rapid prototyping at the edge of the atmosphere, like you really can. I bet you it take them. I mean, a year, maybe two, and they're ready to go through with having maybe even some type of satellite launch that's printing part of itself or something like that. Or it's the tough part is the problem with additive manufacturing and going into space is that you pretty much have to bring the material with you that you're going to make it out of anyways. So
Yeah.
you can't really go add more of it without affecting the trajectory of uh, your ship there. So
Yeah, and what now? The other thing is what happens if have a spaghetti monster, and now what do you do? Reject the satellite and send it back into orbit? I mean, back into the Earth, and back to Earth, and burn up on reentry because, well, guess what? It didn't stick. Um,
yeah, yeah,
yeah, it could be possible. And the thing is that's when you start dealing with larger satellites building microsats. You put little robots on there, and they're building the microsats. Like communication gateways and stuff like that.
right.
Hell, they're doing communication over lasers now. So it's the thing is all you're doing is at that point printing targets.
Yeah.
Printing targets and letting them go. So you can test that type of stuff. So
Yeah, we're getting to a point where even like um I would say your prints get smarter, or even like, we're talking small satellite printing. It probably could even go to some type of space station printing modules of itself, where it's like, hey guys, we're gonna send up this Falcon 9 filled with whatever material that whatever alloy we just developed. We need you guys to build this module for your station, right? And just all you have to do is connect it on, and the printer will make
mhm,
the module connected to itself. I mean, maybe even fused to itself like that.
that makes
As
sense. Yeah,
yeah, I mean, there's just a lot of possibilities.
yeah. And you start dealing with like stir welding and friction welding, and like what we talked about earlier, the cold shot welding. Stuff like that. The
Yeah.
thing is, it's I have to wonder if the first printer to make it to the surface of the moon is going to be the Ender 3.
Yeah, no. See, that was another direction that I could have taken this, like printing in space. Like, okay, we're not. Maybe address the normal consumer. We're not taking your Ender 3 to space. That's not what we mean when we're talking 3D printing in space. That's their standard FDM, or some people would say FFF. But it's something that it's something that I think would be interesting. But at the end of the day, I think it will not work. I don't know what
Well,
about you.
everybody's first printer is an Ender 3. Why can't it be the same? Why can't it be the moon's first 3D printer?
Yeah.
It's one of those, everybody sees as a running gag that everybody starts with the Ender 3, and there's a chance that eventually something is going to start with the Ender 3. However, I think we're going to be dealing with stuff that's a little bit more robust. Maybe, if anything, we'll send up, like a concrete 3D printer or something that can build habitation modules, on board on board the moon surface out of the regolith that's actually already located there.
Didn't didn't Orbital E have something like this that they were talking about? Or maybe I'm thinking it just had like a unit with 3 robot arms on it.
Yeah, that it does.
Okay, I'm thinking of that because I mean we talked about it in the like what 2 episodes ago or 2 weeks. I don't remember. A few episodes ago we talked about printing on another planet. Uh, for some reason that model is just kind of sticking out in my brain as like printing on another planet, printing a habitat, right?
Yeah, Orbital E does have I think it's a quad robot stack that they use with the robot arms from Kuka. Um, you know, uh, shout out to those guys. Hope they're doing well. Sorry we can't see you this year at Rapid, but hopefully we'll catch you next year. Um,
Yeah.
so it's just some of the stuff, especially if you start talking about using pretty much printing itself with itself. We have, the Earth has a simulated moon regolith because we've kind of, dealt with it, for what, 10 years, flying
Yeah,
people to the
couple
moon.
rock, couple
So,
copies. Yeah.
so they kind of know the sand, what the dirt's like, and what the ground is made out of. They're still trying to find the whole water thing in Aliens, but um,
Yeah.
they can at least use that compound. I think you can buy it commercially now, and turn it into some sort of extruded or extrudable material. It might be the first time that we're sending Quickcrete to the moon, but something may happen.
Quickcrete. Yeah. I mean, honestly, it's something that you have to you need when you're trying to like terraform another planet or you're trying to move into like build humanity onto another civilization. You're trying to make even more cities. What's the first thing you have to do when you make a city? You gotta make you gotta make the roads.
Yeah.
Like you got to start with infrastructure, so roads, housing for the people. Then once housing is done, you can create labs, you can create schools, you can create factories and things like that. But it all starts with the housing, and the easiest way that I mean we talked about it with relativity space, making the printing of a rocket ship so much easier, cutting off hundreds of workers that need to touch this thing, hundreds of thousands of hours it takes to make a rocket. The similar thing can be said for the concrete printers in the house that print houses for.
Hmm.
I think they're printing in Arizona right now, so
Yeah.
or New Mexico or something like that.
Now, mind you, when we're talking about, your first thing you do is put down roads. Mind you, if you ever visit the great state of South Carolina, you realize that was not their priority. Um,
Well, not the first place.
so, it was
Well, they
never,
put the roads down. They never looked at them again.
right. And the thing is, I wouldn't say that, we're trying to terraform the moon. I really want to say we're going there for a long periods of time for study and then leaving.
Yeah.
No need to stay there if we don't have to.
Well,
Um, and
it
kind of
makes
move
me
on to
think
something
about.
else.
I mean, yeah, the moon's got to be a rest stop, if anything. The one thing I worry about is that if we continue, like, to add, we're taking resources from Earth and building on the moon. So at some point, those things do have a weight, and what
Yeah,
goes up
okay.
must come down.
I can, yep,
You see what I'm saying? At a
yeah,
certain point, if we try, that's why I say like a lab has to be because it's got to be minimum and it's got to be very calculated because I think we're losing the moon like very slowly. It's like a couple centimeters or something like that. But
mhm,
like when you start building stuff, you'll start realizing that it's coming back. So
right.
I mean, they can add some calculated thrusts to get it back into a certain orbit, but yeah, that's why I think it is. I also think it's dangerous to build on the moon.
And that's where I kind of wonder, and the thing is, as we're dealing with 3D printing and stuff like that, you start really looking towards, SpaceX and their use of Starship. You
Yeah.
can have the Starship, carrying these 3D printers and stuff like that for use, and then you can interlock the Starship. You should be able to interlock the Starships together and create an outpost. And then when you're ready to dedock, you remove one and leave. And stuff like that. The thing is make sure you have a good, blast area, or somebody's going to get caked and God knows what. But that goes back to the fact of prior planning prevents piss poor performance. um and
Yeah, it's true. I
and
mean, when you contract the work, though,
eh, point taken.
check the
Eh,
contractor's work. That's all I'm
yeah,
saying.
yeah, that's definitely a fair point. And it's like, the thing is none of that takes away from the fact of 3D printing in space is hard, but
Yeah.
it's not impossible. It's not. We see them printing, like I said, on the International Space Station. We see them printing in vacuum. We see them printing things that survive, thousands of degrees Kelvin for extended periods of time, on entry and reentry. If you think about it, we're bringing, um, 3D printed engines to and from, Earth. Um, if who is it? Rocket Lab. Rocket Lab has a theory of when in doubt, I'm going to, bullet strike this thing into Earth, and recover it, under a parachute. So they do a splashdown, they pick it up and, load it on the back of a ship and drag it home. Unlike, SpaceX, who, kind of comes hurling down into Earth and, stops on a dime. Um, but the thing is both of their engines are 3D printed. Um, so you start dealing with a Rutherford engine from, Rocket Lab, which is a great engine, by the way. It's battery operated, and fuel pumps are battery operated. It's amazing. But the thing is, it's 3D printed, and we've seen those things take reentries. We've seen the Falcon 9, engines, and also the Merlins, take freaking, reentries. And the thing is you can try and fire them back off again. I believe Rocket Lab it just flew the first reflyable Merlin engine ever,
Oh wow.
on this past launch, or two launches ago. I think they did. They brought it back, refurbished it, and stuck it back on the. I think they even did less refurbishment. I think they just cleaned it off and threw it back on another rocket.
Hmm.
Um, and this is a and this is kind of where you start dealing with 3D printing composites that kind of baffles the mind. You got this machine, you got this engine that just got up to what, a couple thousand degrees Kelvin. You would think you flying,
Yeah.
using like a methalox. Um,
Yeah.
you're getting at orbital speeds, orbital velocities, and then coming out of orbit, screaming through the atmosphere, splashing into water, and
Salt water.
you're salt water. Yep, exactly, and you're still usable.
Yeah. Yeah, exactly. It's impressive. It's impressive because, like, I mean, uh, Tesla figured out with the auto launch, the landing pad that they have, the little boat. To be honest with you, that makes me think that NASA, or not NASA, SpaceX also probably have a way to figure out how to land like that. They can do that on the moon, but they can't hit the moon with a rocket like they can,
Right.
testing here. So you don't get as many opportunities on the moon.
Right. And that's when, because the thing is, if you think about it, their reentry speed, as far as on their engines and stuff like that, and the heat that they're generating, the atmosphere itself is breaking the
Yeah.
actual, the thrust. So, which to me, I still wonder. I want to look into it a little bit more. Is the um um what is it, the plasma, the jet coming around the motors as it's coming back through reentry, protecting those 3D printed components from the heat of reentry?
Yeah, I think are they like it's like are they deflecting or are they absorbing or is there a heat sink of some type? I'm assuming that there's a heat sink that's also assisting,
Hmm.
but it's hard to say because like where would it be?
I know they fire them off, as they're coming in to kind of, protect everything and, coat everything with a plume. But you never know.
Yeah, I mean it's hard. I mean the rocket engines are already they've got to produce the highest amount of thrust. You think about what the engines that jets have, like the F what is it? What are we at? The F-35 now.
Hmm.
Those engines probably about as strong as like two of them could be like a well, because the Falcons have smaller ones. The Falcon rockets. What are they? I can't remember the name right now, off the top of my head.
Yeah.
Raptor.
Raptor engines.
Raptor engines. So like there's Raptor Heavy and then there's a Raptor which like are standard or whatever. Like
Hmm.
if I would say two jet engines could probably equate one of those rocket engines.
Yeah.
But it's about weight versus thrust, right? Because a jet is so much more lightweight. Honestly, what if we could 3D print like that makes me think about 3D printed spaceships as far as like um, maybe in the form of a jet that has some type of thrusters and I know that's long term, right? But at the end of the day, what if we've made our 3D printed rocket? Why can't we make 3D printed, space ships or jets like that?
Yeah.
I think it
That's
would be possible. Yeah. I mean,
that's
they
interesting.
developed a new alloy, right? Like
Right. And
they
we
ha-
do have material out there that is able to put out its own fire. If we think about it, like for example, Prusa Research I saw an email last night, I think, or something on X last night, that they got approved for the UL rating for their PET G.
Oh
So
wow.
so a self-extinguishing PET G. And, just that alone, especially dealing with like orbital mechanics and stuff like that is a game changer because that type of material you can use on the International Space Station. You have to worry about flame being spread. You
Yeah,
know,
and what if you could take that a step further and it could also help with the suppression?
yeah, exactly.
Like you have so what I think of is like okay you see there's a fire in like bay 6 whatever this little kind of robot like a Roomba that has a little baby Kuka arm and some material on it can make its way over probably via some type of rail system and then close a room off with it or
Hmm.
close the area off or close the flame off period with it and suppress the flame.
Yeah, it's pretty cool. The UL for rating is expensive. It's like $50 a kilo. Um,
Yeah.
so it's not like everybody's gonna be playing with it. But the thing is, it's still that type of material is out there, and I know we're printing with high level of alloys and materials and stuff like that on the International Space Station. But sometimes just the easier filaments, like you start talking about the UL filaments, the self-extinction filaments, the ones from not just from Prusa, but also from all the other companies that have them. Um, that's a game changer when you start talking about life, limb, and safety, as far
Right.
as the ability to use that material for stuff that could particularly protect people.
Yeah, and the amount of bravery it takes to go out there with these with like I know there's no one's been on the 3D printed rocket, but eventually I bet you they'd print a passenger rocket, right? I don't know if they've talked about it already, but um,
That I have not heard.
yeah, it would make sense though. I mean, for what do we? Starship's the only one right now that's in the SLS, right? Um, maybe the European Space Agency has a couple ships that they have. Or meh, does Blue Origin still launch people?
Yeah, well,
No,
they do
that's the space
suborbital.
station, I guess. Yeah.
Yeah, no, they do
So,
suborbital.
I mean, that's it's becoming more and more prevalent, but for me, I'm just saying like I would expect just how things go with like wanting to cut costs and increase efficiency. 3D printing is going to be how most rockets will be made, unless it's proven some type of way that they are not as efficient, right,
Hmm.
or stable. But I think we've seen enough of it to know it can make it.
We've sent people ever since SpaceX started flying, people and being rated for human spaceflight. We've seen 3D printing take people into orbit. Um, the capsule and protect them for most of the way because SpaceX's helmets for their crew missions are all 3D printed. The engines that are on not just the Merlins, or sorry, the Raptors, but also the Super Dracos that are on the capsules are all 3D printed. Their combustion chambers are 3D printed. Um, so 3D printing is getting people to space. It's just not the entire surround thing. Um, once we
Yeah, it's
start
hard.
getting the capsule, then we have an entire life cycle.
Didn't they also start 3D printing the helmets for the spacesuits?
Yep. Yep.
So they can make sure that they're formed correctly. So
Hmm.
yeah, it's helping. I mean, in that sense, like going at high speeds or like entering or exiting, like an atmosphere, I can understand wanting to probably be in a rocket for more protection. But like if you're gonna trust your helmet to be um, to hold up in the vacuum of space, like I would assume I would trust a rocket, right?
Yeah, I can
3D
see that.
printed rocket.
I can definitely see that. All your safety features are pretty much 3D printed now. And as we move forward with Boeing's launch in the next couple of weeks, I think Starliner's going back up again. I think they'll start releasing what they've been doing. They're not as open to talk about their stuff as say SpaceX is because well look who the CEO is. Um,
Yeah, you don't care.
yeah, that and well the thing is he's very open about the fact that he wants things to be open source. And that's why he talks to James Dodd and stuff like that, the everyday astronaut on YouTube. And he has those conversations with him, and he explains to him, kind of what's going on, and he walks through the thing. Because well, the thing is he wants to breed people to be not just the next him, but to be curious, to want to build these things, wants to get into these things. Like what we're trying to do with STEM and trying to get people involved in additive manufacturing and subtractive manufacturing and smart manufacturing and the automotive aftermarket. The thing is he's doing that at a bigger level, trying to get people more attention. The thing is it's all interconnected. It's one big giant circle because everybody's trying to help for that one little thing that makes more sense. And so he's very open about that. He's very open source. What he open source the entire layout for Tesla, the first Tesla they ever made, is all of the plans he ever did with that. He released them to the open source. And a lot of that car was 3D printed, surprisingly. Now it's orbiting Mars. But the thing is we see additive manufacturing now in realms we never thought we'd see it before.
Yeah, it's gone so much further than like just printing like at the house or something like that. But I mean, there's many different types. I don't think we have had a episode where we talk about 3D printing food or anything like that. But I think it's also something that like eventually could be possible, right?
Very much so. So technically, if you really think about it, especially touching on that subject, then you can technically go to space with nothing. Unless except for the clothes you need and the materials you need to create what you're going to eat for the next 6 to 8 months.
Yeah, exactly. Like you could have a way to if you have a way to preserve materials, or if you can get a certain weight ratio correct, you don't
Yeah,
really have to launch anything else with you. Like it's something like I think one of the astronauts that was that helped with the first 3D print in space or on the ISS, they were saying like as of now, if there's a failure, they're completely reliant on uh, the workers or um, government agencies working on the ground getting them their supplies. What if they already had the supplies and the things they needed?
yeah,
Yeah,
that
it'd
makes
be
sense.
much more self-sufficient. And honestly, it would be cheaper for all the taxpayers that are paying to put these ships into orbit.
Right, it's cheaper because you can pack more on.
Yeah.
And the thing is, I really think we're going to see more and more and more and more um, happen with 3D printing and orbital rockets and stuff like that. As soon as that three-letter agency decides to get their head out the butt, and release it, better known as the FAA. I think once like NASA's all for it. The FAA, on the other hand, hell, they're still die hard set that this 3D printing stuff doesn't work on airplanes. Or anything that's carrying passengers, which that's been proven wrong quite a few times. But
Yeah, I mean, if you forget the door plugs anyways, you're not gonna work.
right, right, we all can't be Boeing.
You
Um,
miss if you miss a part, it's a missed part, no matter if that part was printed or not. I mean, I think that it's relativity space has proven it at least.
yeah, I think FAA finally got it through their head that hey, guess what? We need to be open to this. Um, This is something that is going to happen. You just hold on for the ride. Sooner or later we'll see it available for commercial spaceflight. I think once we see the ability to use 3D printed parts, which I hear is coming, at least metal ones on commercial aircraft, we'll see an entire industry, an entire age of things take off from there. Because then people will be like, okay, cool, now we can really push the envelope. Um, I think we're there. We're on the way there. I think at least. But
But a few, I mean, all of our astronauts are very
yeah,
bright-minded people. But you get one that's like a little bit too interested in printing, and you're gonna start getting some cool things.
yeah, exactly. And the thing is sometimes I wonder if they sit down with these guys and actually have those conversations. About hey, this is what you can do with a 3D printer, and this is the type of stuff that you can experiment with. This is stuff you can print. As long as we know what the environmental factors are. It's at that point pretty easy to figure out, hey, guess what? This is how you do this. This is how you do this. I'm not sending you up there with with an Ender or a Bamboo lab. I'll tell you that. It's going to be something a little bit more substantial.
Yeah. Yeah, I mean, you need an enclosure of some type. I think it's got to be developed. I mean, it's probably there's the one on the space station now, and they sent the metal one that we were talking about earlier. But there's got to be just like how when 3D printers first came out, there's going to be a lot of different types, like a lot of different makes of the same style, the same system. So, but yeah, I mean, if things get made open source, it's going to be like that.
Yeah. And the thing is open source breeds competition, and competition is good for business. And the thing is competition is good for science because somebody always wants to be better than the next guy. And the thing is then you get the people in there that says, hey, I want to be better than the next guy, but I want to help the next guy. And that's I think where we're kind of at with a few things. I think that we're kind of on that brink of guess what? We need to have these conversations. We need to have this, type of setup as far as, orbital 3D printing to how do we support just not the common good on the ground, but how do we move this one envelope forward that we're all passionate about, and that's spaceflight. How do you
Yeah.
move that forward? And the thing is without additive manufacturing, you really can't.
Yeah, and a lot of things like if you go back in history, you look at like what made um, a lot of innovation or what drove it. Unfortunately, it's conflict. A lot of conflict happens, and you come up with this. Either you stumble onto something that's like game breaking, or you end up having to develop something because you're being either persecuted, or you're trying to take over something, or some type of war maybe, or financial gain. We see a lot of innovation around that, and then some of the other specialty topics that maybe don't affect as many people. Unfortunately, it's probably going to happen a little bit. Hopefully, it doesn't. But when you're going to a new realm, like another frontier, or they call it the final frontier, um, there's going to be a lot of grabbing, because I imagine that we're going to be, if we can get to Mars, why can't we get resources from, like, asteroids, the asteroid belt?
Hmm. Makes sense.
So that, and inevitably, if there's resources, there's going to be some type of a fight for it.
Yeah, I can agree with that. Astronaut, what is it? The mining of the asteroids is, like you said, is going to cause, our fair share of problems. Um, but I really hope that, the greater thing of, you have, astronauts that are from, different continents that,
All work
really,
together.
yeah, exactly, that aren't, the greatest of friends. Their countries are not the greatest of friends, but, they're doing what they have to. Um, for example, we don't have anything right now, going against Russia. It's just, we have their own fair share of, problems. But we're sitting there, what is it, Monday or Friday this week? We're sending a Russian cosmonaut and four Americans to the International Space Station on board Crew 8. Um,
Mm.
so, it shows that, you may not be the best of friends. Your countries may not be the best of friends, at least, but science is science. The greater good is the greater good. Um, and, I really think that, hopefully, with that, where we still keep that mindset that, hey, we're going to build this for the greater good. Um, and I would love to see, all the different space agencies, Roscosmo, Chinese Space Agency, which, that's going to be a push, JAXA, ESA, and, NASA, of course, along with, all the other ones, get together and create a additive manufacturing environment that is conducive to um, scientific growth.
Yeah, I mean, they're all these space agencies are just gaining that notoriety, and they're getting better and better. I mean, India landed the first rover on the dark side of the moon, or the first lander,
Mm-hmm.
and I mean, Japan is launching rovers or launcher or landers to the moon, you know, pretty often. I
Repetitively.
mean, yeah, I mean, just because it didn't work doesn't mean they didn't get there, right?
Yeah, yeah. They speed up on reentry on landing. They haven't quite figured out
Yeah.
the slow down part yet.
Yeah, no, it's hard. I mean, like the innovation in other departments or other fields is it could, like, they're all going to contribute to us getting further. Through additive manufacturing as a whole is going to increase the ability to rapidly change environment, and build into a new environment. But the development in computing and data science, and AI, and things like that, that's going to inevitably drive how easy and how far we can get with some of these automated, landers or rovers, or things like that. I mean, just, can you imagine if Perseverance had a 3D printer on it, and when the Ingenuity drone broke or whatever, it just printed its parts and attached it back?
Yeah, that would be, that'd definitely be something.
Right?
I
Like,
would,
it would be impressive. I mean, that's self-sustaining.
right. And the thing is, the drone was not ready to come out of go into retirement, but due to weather constraints, it did.
You don't get to pick your time. I mean, and also it's hostile. In space, space doesn't want you to survive.
Right, right. It does everything it can to kill you
Yeah.
or kill the machine itself.
And Mars doesn't have really an atmosphere, so you're pretty much in space.
Yeah, yeah. Well, nothing there likes humans, and nothing there likes anything human made.
Some
You know,
methane, right? Methane
yeah.
fields.
It's like once you start going further and further, you start getting to the gas giants. They crush you before you even make an impact. You come down there as a crushed soda can.
Hmm.
Um, so that's like, what is it, Jupiter? By
Yeah,
the
Jupiter's strange because it's the first, like what we see at least is not the surface of Jupiter.
right. And it's like you start talking about like Saturn and stuff like that. You start coming through that. If we can start sending, three. I know we're going to kind of go a little bit over time here, but sending 3D printed, um, um, pieces, into that environment that are solid, and stuff like that, that are full of sensors, we may be able to finally, reach the surface, without it completely crushing something. Because every time we send in a, some sort, and I know the signal dies after the first couple thousand feet, but, at least we get something there. Right now, we're getting, tin can junk, to the surface, even if it makes it, which I don't, most of the time, I don't think even it makes it there. I think it burns up
No,
on reentry.
yeah, that's also something that is pretty tough. We're losing some of those resources that um, we're not getting back the resources. No return on investment's a little bit limited on some of those things, those failed missions, and I mean it's the risk of innovation,
Yeah.
but it's unfortunately sometimes we have to fail before we get it right. But thank God Neil Armstrong took the controls when he landed. Um,
Yep.
so
Yep. Or that would have been
yeah,
a fun problem.
it could have been a lot worse.
Yeah. Could have been a little bit more hairy than he would have wanted.
Yeah,
Definitely need new shorts on that stop.
yeah, yeah.
You know, and the thing is, hopefully, additive manufacturing helps with anything space related. We're all for it. We're all to support it too. Hopefully we get involved with a little bit of it too. We'll see. But, I think that brings us to the end of this week's episode.
Yeah, you're gonna have to stop us. We're gonna keep doing this rabbit hole thing.
Yeah, yeah, I know. And the thing is I want to take time and I want to say thank you. Thank you to every single person who's tuned in to listen and who continues to tune in. We're at 2,241. I have been seeing a lot of people tuning into the episode on YouTube. So, while you're there, go ahead and subscribe. We do get a couple likes. So, go ahead and like and subscribe on the episodes that you enjoy. Leave us a comment, where you're from, what are you working on? Just so we can see it. We'll respond back to you, I promise. And whenever we do get the new 3D scanner, I'll make sure if it's just me or if it's everybody, we'll do an unboxing of the 3D scanner to show everybody what it is. Get everybody kind of excited about it, have a little bit of fun with it.
Yeah, I'm curious to scan.
So, and the thing is go out and check out our other stuff that we got going on, the blogs, stuff like that, the shorts. We're going to be adding more and more to that. I promise. It's been kind of hectic lately. Going for a doctorate really doesn't help anything.
No,
So
split for time.
right. So, from my side, I want to say thank you. I appreciate y'all, and I hope y'all have a good one.
Yeah, and I echo Nick here. Pretty much always very appreciative having a platform that anyone would listen to, or even if you're not listening, it's still nice to have the platform. And I mean, we definitely see listeners. So if you guys are interested or curious or have questions on anything, go ahead and toss some questions towards us. We have definitely we've got Instagram, X. You can go to the website Volcanara, check out the printed heritage and all that stuff too. You can get some nice lithophanes and things like that. And if there's any questions or concerns or even requests that you guys have, we're open to hearing them. So.
And we're definitely, planning a live stream or a set of live streams soon. Maybe do a Volcanara,
we got to make sure he's moved in.
Do a power hour or something like that with everybody. And have those conversations and, maybe start a Patreon soon. So we'll see, kind of do a little bit of something special with you. So,
yeah.
But, thank you.
Yeah.
Y'all have a good one.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanar Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.